thing we're going to do is, now that you have an empirical formula, we are going to put it into molecular formula. Okay. So overview on how to do that. We know that empirical describes the lowest ratio, but molecular would describe the actual molecule. Sometimes those are the same, like CO2, you can't reduce that any further, but that's the actual molecule. But there are some that are bigger that we can also write in a reduced format. So we can have the empirical that's different than the molecular. So in order to do this, we need the molar mass. And then we look at the ratio of the empirical to the molar mass, and it's going to tell us the molecular formula. Okay, and it must give us whole numbers. So just like with the other ones, if you get a weird fraction, you multiply to make it a whole number. Okay, so here is how we're going to actually do this. Okay, we're going to calculate the empirical formula. Sometimes it'll be a nice question and that will be given to you, but a lot of times it won't be. So you're going to calculate the empirical doing all of the same stuff that you just did in the previous examples. Then you're going to calculate the empirical mass. So once you know the empirical formula, you just calculate the mass of that compound. So the molar mass, but it's called empirical because it's the empirical formula. So you do the same thing where you take the subscript times the element's mass. Okay, then you're going to take the molar mass and divide that by the empirical mass and multiply all the subscripts in the empirical formula by the value that you get when you divide. So here's an example. Sounds more complicated, I think, when you list the steps than it really is. So first thing, here's our problem. A compound is made of only sulfur and oxygen. It is 69.6% sulfur by mass. Its molar mass is 184 grams per mole. Okay, so we want to find the molecular formula. Oh, there it is. Determine the molecular formula of this molecule. So the first thing we need to do is actually figure out the empirical formula in order to find the molecular formula. So we're going to do this the exact same way that you just did it in the two examples before. So you're going to take that 69.6%, put it as grams, divide it by the molar mass, and that's going to give you 2.17. Okay, one thing that makes this one slightly different than those other ones is that they only gave you one of the percentages. But remember that percentages always add up to 100. So if you know that the sulfur is 69.6%, then 100 minus 69.6 will give you 30.4. So the nitrogen must be 30.4. Okay, so then you just do the same thing. Take your 30.4 grams, divide by the mass of nitrogen, which is 14.01, and that gives you 2.170 moles. Divide them both by the smaller. In this case, they actually happen to be the same. So both of them come out to be 1 when you do that dividing. So the empirical formula is SN. And you would actually list that by putting the less electronegative element first. We haven't really gone over electronegativity, so you might not know which one goes in which order. So for right now, either order is okay until we learn about electronegativity. Okay, why is my slide not changing? Come on, there we go. All right, so a compound is made of only, oh, sorry, I'm rereading the question. I got distracted by my slide not changing. Back to the problem. Okay, we have our empirical formula. So then the next thing to do is to find the mass of the empirical formula. So SN, so the mass of 1 sulfur plus the mass of 1 nitrogen, gives the empirical formula mass to be 46.08. Then you take the molar mass from the question that they gave you and divide by that empirical mass. So 184 grams per mole divided by 46.08 grams per mole gives you 3.99, which we're going to round up to 4. Last step is to multiply all the subscripts from the empirical formula by that answer that you just got. So our empirical was SN, so we multiply those by 4. It's going to be S4, N4, okay? And if you left that as your answer, that's fine. Like I said, we haven't really gone over electronegativity, but when we do, you will see that nitrogen is a little bit less electronegative than sulfur, so we would write the N part first. So N4S4. And that's it. So it's a lot of steps, but if you just take it one step at a time, it's not too bad. Okay. All right, so here is another one for you to try. Again, like with the empirical, I would recommend that you pause right now and actually try doing this on your own to see how it goes, where you get stuck, if you get stuck. You can look back at the example we just did. So I would pause right now so you can actually go ahead and try doing this problem. Okay, hopefully you have completed the problem. Here are the steps worked out for you. So first thing you're going to do is find that empirical formula. So put all your percentages as grams, divide them by that molar mass. Okay, so that gives you these different values for moles. A lot of these you're going to see, you can kind of see it as you're doing it, like, oh, I can tell that this is going to divide nicely. So a lot of times you're going to be able to kind of see that as you're going, and that's a good indication that you're on the right track. There will be those rare examples where you'll get that 1.5 or something where you got to multiply, but a lot of them are going to give you the nice whole numbers when you divide. Okay, so after you do that, you get your empirical formula CH2O. Calculate the mass of that empirical formula. So 1 carbon, 2 hydrogens, 1 oxygen is giving you a mass of 30.03 grams per mole. I don't know why the slides don't want to change in this one. Here we go. Okay, step 3, divide that molar mass from the question by the empirical mass. So 180.18 coming out of our question right here, divided by 30.03, and that gives you 6. Again, it's a good sign when you get a nice whole number. So then we're just going to multiply all the subscripts by 6. So we end up with C6, H12, O6. That's probably something that you've seen before, right? So this is a nice example of when we can have a molecular formula, but it can also be reduced as an empirical formula. Okay, and we're going to stop there. Stoichiometry coming up soon, but hopefully after today's podcast, you are able to calculate empirical formula and then also take that a step further and calculate the molecular formula. If you have questions, please bring it up in class, but we are going to do some practicing with this as well. Thank you.